Hello coding champions, welcome back to Strictly Coding. I'm sure many of you know both C++ and Java, and we know that in C++ we have the flexibility to create an object instance in different memory space. If you declare a global object, um, you can have the memory in the data segment. We can also declare a local object inside a function or a class method. In that case, the memory will come from the stack. If we want, we can also use a pointer and allocate dynamic instance using new operator, new keyword, and assign the allocated address to a pointer. But we know that in Java, we can only have dynamic instances uh, created from heap using new operator. Now, why it is like that? In today's video, we're going to explore that. Let me explain. Hey, this is Subrata Kumar Dey. I am a university teacher teaching computer science courses over 1.5 decade. If you are a coding enthusiast or new to this channel, consider subscribing and share with your friends. Also press the notification bell so that you don't miss any future update. Okay, before I show you anything on the screen, I'll be discussing the various logical segmentation of the memory that becomes available when you execute an application, both in C++ and Java. We will also talk about the memory leakage and garbage collection mechanism, so that at the end of the video it becomes clear to us why Java enforces to have dynamic instances always from heap. Okay, so stay tuned till the end of the video. Okay, so if you look at the diagram here, first I'll talk within the context of C++, and as you can see there are 4 segments: code segment, data segment, stack segment, and heap. Now if you look into the code segment where your machine code of the program is loaded, so that's fine. Now if you declare anything global, including variable and global objects, that will be allocated from the data segment. Anything local, including the function parameters, or if you declare any variables or object inside the function or a method of a class, that will be allocated from stack. And if you want to allocate a dynamic instance from heap using new operator, new keyword, that will be allocated from heap. Now I have written a sample program in C++ as well as in Java, so I will explain the utilization of this memory with the using that sample code. Okay, so let's see. Now we have a C++ code. Now we have a class A, so object 1 is a global object which is declared outside the main, and we also have a global integer gx whose value is 10. So this gx and object 1 is allocated from data segment. Fine. Now if we look at the main, it has 3 local variables: one integer x whose value is 12, then object 2 which is an object of class A, and also ptr which is a pointer to the class type A. So therefore the memory for x, object 2, and ptr is allocated from the stack. Okay, so for integers 4 bytes. So for global x, let's say the byte number 100 and 103, 10 is stored there. Okay, so that is the global gx. For object, how many bytes, we are not sure because I have not talked about the fields, so that's not important here. Now let's assume the starting byte is 110, so that is the starting byte for object 1 in the data segment. In the stack segment, the local integer x, let's assume the bytes are 200 to 203 for object 2, which is the local object, and let's say the starting byte number is 210. Now pointer also a local to the function because it is declared inside the function. So memory is also allocated for pointer, let's say 220 to 227, 8 bytes. Now it can be 4 byte or 8 byte depending on the addressing. If the addressing of that machine is 32 bit, then it will take 4 bytes. If it is 64 bits, then it will take 8 bytes. So we are assuming this machine use 64-bit addressing, so let's say 220 to 227, and these bytes will be used to store the byte number of an allocated memory. So when you say ptr equal to new a new instance of object uh, type A is created, and let's say the starting byte number is 300, so which is stored in ptr. Okay, so far so good. Now what are the life cycle of this memory? Now if you see, the life cycle of gx and object 1 will be the life cycle of the program. Okay, so as long as the program will be executing, they will be there. Okay, because they are global. Okay, now the lifetime of the lifetime. Okay, the lifetime of the local variables, in our case x, object 2 and ptr, will be the duration as long as the function or method will be executing. Okay, so it could be, instead of main, it could be any other function. So whenever a function returns the control back to its caller, all the local variables will be released, no problem. And when it will release ptr, now ptr is pointing to address 300 in heap, so this memory also will be released from heap. So this is fine as long as our program terminates according to the expectations. Okay, but it may not happen always, and things can go south. So what happens if your program crashes? There can be some runtime exception, runtime situation. So your program can crash, or due to a bad piece of code, we can have memory leakage, and those memories cannot be released. Okay, and that is why the concept of garbage collection comes into picture. Now releasing memory is somehow automatic if everything goes well, but if thing does not goes well, or we write a bad piece of code, then we can actually have some memory leakage, and in that case what will happen? That is why garbage collection comes into picture. So many programming languages have automatic garbage collection, many do not. Okay, so those do not, actually the responsibility comes largely on the shoulder of the programmer to actually participate in the memory management up to some extent. Okay, now Java actually has the automatic garbage collection mechanism, and that is why the memory management thing is become an abstract thing for the programmer. So programmer actually don't need to do anything about the memory management. Okay, even there is memory leakage, the automatic garbage collection actually will reclaim those memory. Okay, now what is memory leakage, and why heap actually used, or heap is the contributing memory where the memory leakage occurs? Let's talk about that. Okay, now memory leakage is when we have a memory and we do not have any reference from our program to access that memory. So that's counterintuitive, isn't it? Now what I mean that we allocated some memory and we have a mechanism to actually access that memory, for example using a pointer or using a reference. Okay, now if we change that pointer and make that pointer to point to some other memory, and we did not release the previously allocated memory in the heap, because heap is unnamed memory, we don't give any name like variables, we use a pointer to point to that heap memory. Okay, dynamic memory. Now without releasing the pre-allocated memory, we are allocating a new memory and making that pointer to point to that new memory, then the previously allocated memory have no reference available within the program, and that becomes a memory leak. Okay, so if we write a bad piece of code and if we have enough memory leak and these leaks accumulates, then it can actually, like the Pac-Man, it can actually eat up the free space, and it can actually reduce the heap size and make our overall execution of our large program slower. Okay, and that is why it is important that the unreferenced memory or the leaked memory need to be reclaimed. Okay, so Java actually has the garbage collection mechanism, and that is why Java do not allow us to create instance in the stack segment. Okay, for Java of course data segment is irrelevant because we cannot have anything global in Java. So I have written the equivalent Java code for the similar program. Now here you can see that we have the class A. Okay. Now in main class we have a main method. So the Y, object 3 and object 4, all of them are local to Java. But if you look at the C++ piece of code, whenever you declared object 2, the instance is created in your stack. Whenever you declared object 1, the instance is created in the data segment. Okay. Now of course you also could create instance in the heap using a pointer, okay, to point that. Okay, but there is no issue in creating instance in stack and the data segment for local object and the global object. But in Java, if something happens and if that instance lose its reference, then it needs to be recollected, and that is why the Java garbage collection actually examine the heap for the recollection of the reclaiming the unused or unreferenced instances, and that is why Java enforce us to use the heap. That's why Java requires us to create all the instances dynamically from heap. Okay. Now we need to understand what is memory leak. Okay. Now see, here let's again consider this C++ piece of code. Now we have a pointer. Now we are telling ptr equal to new A. Okay, so according to our diagram, ptr is pointing to the new instance A, which is from the byte number 300. Okay. Now after some time, after doing something, again we are creating a new instance. Okay, so now a new instance is created here, let's say from byte number 350, and ptr will be now pointing to this new instances, which is from 350, and this 300 will be overwritten by the byte number 350. Okay, so ptr will no longer point to the previous instance. Now ptr will be pointing to the new instance from 350. So according to this code, whenever we create another instance will be created here, and let's say from 350, and ptr will be pointing to that. Now this instance, which was previously allocated for this line, have no valid reference to access it, and that's why this particular memory is a leakage, okay, in your heap, and that need to be reclaimed. If there is no automatic garbage collection, then that leak will remain there, and such leaks will accumulate and reduce the heap size and eventually slow down your machine. Okay, and that is why it is important to have either the programmer need to manage the memory management, participate in the memory management by debugging and examining his code so that it does not create unnecessary memory leakage. Okay, or else like Java actually takes care of that by automatic garbage collection. Okay, so I'll show you a, okay, so in that corresponding code that I was talking about, you see in the Java piece of code, now we have declared object 3 and object 4. Now see, unlike C++, object 3 and object 4 is not instance yet. Okay, in C++, whenever you declare object 2, they become instance, memory is allocated from the stack, and the default constructor is fired, and all the fields are assigned default values. Okay, but in Java, they are not yet instance. Okay, so they are just the reference for the future instances from heap. Okay, that's the difference. So we can call them object handle. So right now, actually, object 3 and object 4 is no instances, okay, unless we create the instance from heap. Okay, and that is why we have to say object 3 equal to new A, and since constructor can only be fired when memory is allocated, so constructor is fired here. Okay, for default constructor, if you have parameters, you can give the parameters inside. Okay, okay, so now according to this, whenever we call this object 3 equal to new A, this instance is created in heap, and object 3 will be referring to that instance in heap, okay, and so does for object 4, okay, according to this code. And that is why, even though we have declared y, object 3 and object 4 as a local inside the function main, method main, okay, for y memory is allocated from the stack, but object 3 and object 4 does not represent instance. So for object instances, memory is actually allocated from heap, and we had to do that using the new keyword, okay. Okay, so because if there is memory leakage, they will be reclaimed from the heap by the Java garbage collection module, okay. So Java garbage collector is a module that actually keeps track of the instances in the heap, and whenever an instance don't have any reference or it is not being referenced for a certain amount of time, that garbage collector actually reclaims that memory and give it back to the heap for future allocation, okay. Pretty simple. Okay, now I'll show you a Java code. So I have created a Java project using NetBeans ID, and I'll show you. I'm purposefully actually create some memory leakage, and I'll show you that how Java garbage collector actually reclaims those leaked memory back to the heap. Okay. Okay. We need to remember though that Java garbage collection, we don't need to call it explicitly, okay. So Java virtual machine actually keeps track of all the instances, and whenever it deemed fit, it actually invokes the garbage collection mechanism, okay. So of course, if we terminate the program, all the unreferenced instances will be recollected, reclaimed, and given back to heap for future allocation. But to demonstrate you, I will call the garbage collection module explicitly to show you that the leakage that I am creating intentionally are actually reclaimed. Okay. Okay. So let's see the code. So if you look at the screen, we have a book class. Okay. There are constructor. Okay. Fine. Now in main class we have two methods. One is do sum, another is main. Okay. So main is static, so from main we'll be calling do sum. That's why do sum is also static. Okay. I can have dedicated future video on static versus non-static fields and methods. Okay. Okay. Now in main we have created two object handles, b1 and b2. Remember, they are not instances unless we allocate memory. Okay. So we are creating instances for b1 from heap, and we are creating another instances for b2 from heap. For b1 the default constructor, for b2 the parameterized constructor will be fired with the parameter value. Okay. Now control is in main because we are executing main, and we are printing the total memory which is allocated by the operating system to the Java virtual machine. So that will show us the total memory in terms of bytes. Okay. So in runtime class we can actually get a runtime instances, okay, and we can make that client to call the total memory. So for that particular runtime instances, how much memory is allocated by the operating system given to the JVM, that will show in terms of bytes. Okay. Typically it's in megabytes. Okay. Okay. Now it will also show us, we can also see here the maximum memory that can be used, attempted by the JVM while actually executing our application. So we can check that how much memory is JVM attempting, okay, for execution of our application, and how much free memory is there in the heap. Okay, we can also check that after actually allocating these two instances. Okay, now we are, after that we are calling the do sum. So we'll have some figures there, and then we are calling the do sum. Now in do sum, what I'm doing, I have another object handle b3. Okay, now I am creating instances so many times. Okay, so you see I am creating instances so many times in the heap, one after another, one after another, but all the instances will be referred by b3. So if we look into the figure again, So now in main we have declared b1 and b2, and the instances are coming from heap. So b1 equal to new book, okay, b2 also equal to new book, so no problem. Now we call do sum. In do sum we have b3, and now we are creating instances in a loop, but we are assigning those instances to the same handle b3, okay. So I'm actually creating some memory leakage intentionally, okay. It's not a good piece of code, but just to demonstrate you, okay. So what happens when the loop executes for the first time? So b3 equal to new book, so instance is created in the heap. b3 is representing that instance, okay, as a reference. b3 refers that. But when loop repeats, then again a new instance is created here, and then this link is cut. Now b3 will be pointing to this one, so that becomes linked, and it continues, okay. So in the last iteration, the last instance will be created, and finally b3 will be pointing to that, okay. So and rest of the instances created before will be leaked, and those leaked instances will not have any valid reference, and neither they will be referenced for a long time because they don't have any valid reference, and therefore the Java garbage collector will be reclaimed all these, so many, okay, so many of them I have created, okay, sorry, not this one. I have run the loop so many times, okay, and so many instances uh, will be there in the heap as the leaked memory, and they all will be reclaimed by the Java garbage collector, okay. They will be reclaimed anyway at the end of the application, but I just wanted to demonstrate you that we can also call the Java garbage collector explicitly to show that the memories are reclaimed, okay. So how can we do that? So okay, so after actually allocating so many instances and creating so many leakages in the memory, eventually we'll have only one valid reference. So v3 will be pointing to the last instance out of these many, okay. How many of them? 1 2 3 4 5 6 7 8 1 billion instances, okay. Okay, so we are actually checking the free memory, and we'll see that quite a bit of memory is already lost from the heap, okay, because of those memory leakage, because eventually we'll have only one instance that we can refer, okay, which is b3, but it will be referring to the last instance. But before that we have created so many instances, and we cut those references, and they actually consume the memory, and we'll see that free memory has reduced significantly. So after coming back from do sum, we can control back to main, and again we can see the free memory, okay. So this is the free memory that we'll see there, okay, same value I think. And then we'll call the garbage collector explicitly, okay. In the system class in Java, there is a system class, and system class has the method called gc, which is garbage collector, okay. That will actually reclaim, okay, all the unreferenced, okay, or the leaked instances from the heap, and reclaim back as a free memory and given back for the future allocation. So after calling the garbage collector, we can see that our free memory has been increased again, okay. Even it can be more than what was initially, because behind the background there could be some other instances which are released meanwhile, so they also will be reclaimed, okay. So let's execute that and see the effect. Okay, so as you can see, total memory is 1 2 3 4 5 6, okay, so 128 million. So it means roughly we can say 128 megabytes, okay, more than 128 megabytes total memory, which is attempted by the JVM, okay. And maximum memory is 1 2 3 4 5 6 1897, so which is 1.8 gigabyte, okay. So roughly 1.8 GB memory. This laptop has 8 GB RAM, so out of that almost 2 GB can be given to the JVM, and JVM actually attempted 128 megabytes for this application, okay. and the free memory is out of 128 megabytes is roughly 127.5 megabyte. Okay. After allocating two instances, which are B1 and B2, now it goes to do sum. Now in do sum, we actually run the loop and create a lot of damages, and caused a lot of damages into the heap by creating those memory leaks, and then we see that it was 127.6 megabytes. Now it is 124 megabytes. So 5-6 megabytes of RAM is actually vanished. So your heap size is reduced by several megabytes. Now after do sum, control come back to main, so we see the same value. Now we call the garbage collector here, system.gc, and that actually reclaims all those leaked instances, all those unreferenced instances which was intentionally created. And now if we see the free memory again, it is 127, and it is even more than the originally which was there, after allocating B1 and B2. So that is the power of garbage collection. So we actually don't need to worry about the memory leakage or running out of the memory. And garbage collector module in Java works on heap, and that is why it is mandatory for us to allocate instances from heap. One last thing might come in your head, that is in case of string, for example, if we have a string S1, we know that string is a class, so S1 we can write, we can simply give a literal, we can simply give a literal like this, equal to let's say hello world. Now we are not actually calling any new. So that's the way of the syntax, but basically an instance is created, but it has a difference between this and creating a string instance like that. Let's say string S2 equal to new string, and the hello world is the parameter. So there are differences, but in both cases instance will come from the heap. But there are actually fundamental differences in terms of number of instances, but I'll talk about that in detail in another video dedicated to the string in Java. Hope this helps. If you like this video, please give a thumbs up, share with your friends, and feel free to comment. So I'll try my best to answer your comments. And thanks for watching. See you in the next video. Peace.